Okay, so welcome to Salting Things Up in the DevOps world. I'm here with Juan Manuel Silva, salty guy. Give him some claps.
Right. Thank you all for coming. For those of you who've been here last year, I gave a similar talk. This is going to be a little more in-depth, so let's get started. Let's see. Okay, let's get the boring stuff out of the way. My name is Juan Manuel Santos. I work as a team leader and a support engineer at Red Hat. I'm also one of the organizers of CISARMY, which is the Argentinian System Administrators Community, and Nerdearla, which is a local co-working/tech conference event that we do every year in Buenos Aires since 2014. I've been using Salt for a couple of years now, mainly with no regrets, or with all regrets, whichever you want to choose. Let me get a disclaimer first, so let's get this out of the way too. I am only a humble user of Salt. I have tinkered a bit with the code. I have submitted an ugly patch, but not much more. And I only had 3 days to prepare this, so who doesn't like pressure, right? My thanks go to the Europython team for managing to squeeze this talk in. So, why Salt? As you may or may not know, Salt is a configuration management system. In case you don't know what that is, think Puppet, Chef, Ansible, but only better. And why do I say better? It's because it's written in Python, and it leverages YAML and Jinja. Now, I know some people in the room might not like YAML, but you can also use JSON if you want. It is relatively easy to understand, and I said relatively because it has some complex things, but what it lacks in simplicity of reading and understanding, it makes it up in being extremely powerful and giving you a huge amount of control over what you can do with it. Some of this will be seen in the next few minutes. And one more detail that frequently gets lost in translation. Salt can work without an agent in the case you don't have root access or you're not allowed to run the agent on your machines via SSH, much like Ansible does. So, previously in Europython, as I said, last year I gave a talk. This was mainly an introduction, speaking of the basic mechanics and terms and concepts behind Salt. As a quick recap, Salt has a master minion architecture, where the master is the one that gives out the orders, and the minions are ordered to do minion stuff. It does so by defining states and high states. The states are representing the state a system should be in, and the whole collection of states that should be applied to a system is called a high state. Another core concept is that of matching, which means targeting your minions and to determine which states apply to which minions. And finally, there's the concepts of grains and pillar. Grains being information sent from the minions to the master, and pillar being information sent to the master from the master to the minions. Sadly, and I have to say this, still no Python 3 support. Salt is still in Python 2. It's getting there, though. There's a big issue, and hopefully we'll get there. As usual, it's not because of Salt, it's because of the Salt's dependencies. But anyway, moving on. 2 more concepts that didn't make it to last year's presentation are those of the mine and the syndic. Now, the mine essentially gets data from the minions, is sent to the master on a regular interval. Now, even though this is done on a regular interval, this is not useful for metrics because only the most recent data that you collect is maintained. Another thing that might confuse you is that all the data is made available to all the minions. So when you query it, you might get the answer of the same data from all the minions at the same time, which can be quite confusing. In fact, you might be wondering isn't this like grains? Isn't what grains are supposed to do? Get data from the minions, send it to the master. Kind of. Thing is, the mine data is updated more often. The grains are mainly static. They're only updated if you purposefully update them, which it's not something that you would usually do. Also, if minions need data from other slower minions, the mine acts as a kind of cache. So there's that too. And okay, there are two ways of defining which mine functions you want to collect from the minions. In the case of normal operation of salts, you would do so either on the pillar or on the minion's configuration file. In the special case of not using the agent, as I mentioned before, you have three ways. Since you don't have the minion's configuration file, you can either use the roster, the pillar, and the master configuration file. And so, a quick example of what the salt mine will be, so that you don't get much too confused, but I promise you will get confused. Looks like this. So let's say we want to first target all the minions in our web servers group. We are going to be applying a mine function to gather the IP addresses of the first network card every 5 minutes. So this we can later use, for example, in an HA proxy configuration to populate the server list. Now, I know that you might be getting baffled by all the ginger here. Try not to think of it. The important thing to understand here is that should we add a new host to the web server group, within 5 minutes we can have its IP address up in the HA proxy configuration file. This is all thanks to the mine, which we can configure the interval of updating. Now, before we continue, since we already mentioned that Salt has a master minion architecture, there's an inherent topology to it. So let's talk a bit about that. The most common one would be one-to-many, meaning one master, many minions. But of course, this is boring, this minute scale. This also kills cat during lunar eclipse. So what are the alternatives? How much can we toy around with this? Could we have, say, more masters? Could we have a multi-master topology? And I don't know if there's any information security guys in the room, but if you are, you're going to love this question. Could we implement segregation? Meaning, could we segregate part of the infrastructure, split it so they don't communicate with each other, but, you know, there's still a functioning Salt infrastructure. And coincidentally, now I'm wearing the right hat apparel, let's answer those questions with another question. So, what if we try more power? So to solve this, there's something called the syndic node. The syndic node is an intermediate node type which acts as a pass-through. The aim of it is to control a given set of lower-level minions, which means that in the case of the syndic node, we're going to be having two daemons, the syndic and the master. Optionally, you can run a minion too. So the way it works is something like this. The main master, which now we're going to call the master of masters, you're going to see why, even though it's already a funny name, sends an order to the minions and to the syndic node. The syndic node relays those orders to the local master that is running in the same machine, and then that master gets the orders and relays them to the lower minions. So now, our syndic node is actually called the master of minions. And, well, this, of course, works the other way around. When some of the lower-level minions reply to any orders, they go first to the lower-level master, then to the syndic, and then up to the main master. So if we have the master, which now is our master of masters, it can have as many minions as we would like connected to it. Then we can have a syndic node, for example, syndic master of minions node, which can also have any given number of minions connected to it. But the good thing about this is that we can even nest levels of syndic, one over the other, and have as many minions as we like. So the topology here, it's kind of up to you. So the only places where you're going to have to ensure connectivity is where the lines are. So how do we actually do this? The configuration is quite simple. On the syndic node, we're going to be setting the syndic master directive. This should point to our main master. We also have to define an ID here, because syndic node takes the ID from here. Then on the master node, of course, we have to tell it that we're now ordering other masters. We are now in control of syndic nodes. In the case of the minions, they should have the lower level minions, they should have the IP address of the syndic node in their configuration file. Just a few more steps. We run the syndic node, of course. And on the main master, we're going to have to accept the key, because essentially there's a new key that gets generated. So now you might be getting the idea behind this talk is to make you think of the possibilities. You could have different syndics per environment, development, QA, production. And you can also have different syndics to comply with some security standards that you might have, or that you might want to come up with. And just to mention it, we can even do multi-master with this. We can have syndics and many masters, main masters. We will not cover it here, but just know that this is possible. So that's it for mine on the syndic node. Now we're on to more heavy metal stuff. Our first stop here is going to be the event system. So what do you think an event system does? Of course, it keeps track of events. But that's not the only thing it does. The important thing is that events can be acted upon. And this system is also the base of the rest of the systems that we're going to see in this talk. In essence, this is mainly a CRMQ pub interface. The important things to understand here is that every event has a tag which allows for quick filtering and identifying an event, and also has an amount of arbitrary data inside of it, which tells us information about the event. So, with just a simple command, run in the master, we can already start watching for events, start watching what's going on. We can also use this other command to send a random event that we are, just making it up. You can see that this would be the tag. Those would be the data of the event. The data is mainly a JSON string. In Python, it will be a dictionary because, in fact, you can also send events from Python code, from pure Python code. And if we did things right, after send the event, this should show up if we were watching attentively to the event bus. We can see that there's our tag and there's our data. Okay. Now, another interesting bit I didn't get to make the distinction last year. There are two kinds of modules, of state modules actually. The first one is the execution modules, and the other one is the runner modules. So the execution modules is the main kind of state that you see in Salt. It means something that is going to be run on the minions, whereas the runner modules are going to be run on the master. And these runner modules can be either synchronous or asynchronous. They are added via the runner directories configuration in the master file. And that's the best part. What do we put inside that directory? Pure Python code. So runner modules are essentially Python code. And an addendum to this, since we just talked about events, any print statements that we put inside our runner modules will be converted to events. So if we do this inside a runner module, we will get something like this. See that, okay, the tag is not quite nice, but there's our data. So even though you can write runner modules, and you're certainly welcome to do so, it is tempting, but there's actually no need. There's already a full list of runner modules available in Salt in the documentation. So feel free to check those out. Now, wouldn't it be nice to live in a place like that? Sadly, we're not talking about those kind of beacons, but kind of. Salt beacons are like those concrete towers with a light bulb on top. They're also a kind of signal, or something like that. They use the event system to monitor things that are happening outside of Salt. And when something happens to those things, a notification is sent, which is actually an event. So those are configured via the minions configuration file because we're actually interested in the minions at this point. And any system administrators in the room? Anyone? Okay. Does any of this ring a bell? Something that is, notifications? iNotify maybe? Okay. Yeah, I mean, iNotify, which is a file system monitoring API to track changes on files and directories, kind of looks like this. So, in fact, there is an iNotify beacon which you use to monitor changes to a certain kind of file, in a given time interval. And there you have it. Anytime the resolve.conf file changes, we now get an event. There's also other types of beacons, for example, a process. We can be monitoring whether or not a certain process with a process name we specify is running or not. If it's not running and it starts to run, we get an event. If it's running and it stops, we get an event. So kind of nice, right? There are actually several beacon types: memory, disk, system load, network settings, the works. There are really a lot, and they're growing. I'm just going to leave you can also write your own, of course. Just going to leave you the documentation here so you can check it out later. Now, this is where things are going to get a little bit more interesting. Yeah, like that. It would be nice if actually the reactor was like this. Believe me, it's actually close. So, what is the salt reactor? As its name implies, the main job of the salt reactor is to react, but not react in a JavaScript way, thankfully, to react in a salt way or salty way. In other words, the reactor is the component that is responsible for triggering actions in response to events. So now you see why we saw the event bus earlier. Of course, we need the event system first, but what is an action? Since we're in Salt, an action is essentially a state that we define. And what is actually going to happen in reality goes something like this. Something is going to happen. If we do things right, there's going to be an event, maybe because this something was being monitored by a beacon or something else. And the event is going to be picked up by the reactor, and the reactor is going to translate that event into an action, or actually a state. Reactors are defined in the master's configuration file. It's a component of the Salt master engine. As we said, the reactor will be making these associations. The associations, if you remember what an event was, you remember that it had a tag. So the association is made via the tag. So we put a tag in the configuration file, and we define which states are going to cover that action. Syntax here is quite clear. Do note that there's an asterisk there. We can use wildcards because some events are fired by more than just one minion and have the minion ID in the tag. So for example, this first one here is the event of a minion starting up. So if we want to match all the minions starting up, we just put the wildcard in the right place. Okay, so this whole slide is actually the main reason I'm here. It's the one thing I spend the most time while working with Salt. So I ask you to please bear with me. There are a few caveats. The state system that we just saw here, those are states living inside the reactor. The state system is actually rather limited, and you can easily skip this while you're reading the documentation and trying out your reactor states. Trying to run things that would normally work in the rest of Salt, in the rest of the states that you have, might not work here. You will find that things are missing, and for starters, forget about grains and pillar. Grains and pillar are not available in the reactor. If you choose to use those, you get unexpected results. Also, reactor states are actually processed sequentially. They're first rendered, and the data is then sent to a worker pool. But since they're first processed sequentially, you're going to want to make your states as simple and as small and as fast as possible. So, after long hours of fighting over the reactor and tearing what little hair I have left on my head, This is the short version. Do not handle logic in your reactor states. This might be a bit too confusing because what's the point then? But I'm going to explain it in a bit more detail. You should use your reactor states for matching and then decide which minions to which states based on an event. And then just call your normal salt states that you have lying around. Do not try to add some logic here. You're going to spend a very long time and you won't be happy about it. So I don't know if this is actually true. It's what it looks like from the outside. It appears there's a disconnect because we're talking about two different engines, even if it's under the same daemon. I like to think it's because of Python namespaces, but I could be wrong. But so, too long didn't read, do not handle logic there. So, as we said, with the reactor we are associating events to states. So if we have our custom event and we have our custom reactor state file, the idea is to keep it as simple as this. And if you really have to do complex things and ensure that many things are done when a given event is fired, just put those inside the long-running and complex state. So once the reactor parses this and sends it to the worker pool, this will be running on the main salt namespace, so to speak. Okay, so what can we use a reactor for? One good example is auto-accepting all the keys of all the minions in our environment. It's quite a hassle. Every time you start a minion, you have to go to the master, accept the key, and so on and so forth. So, as you might have guessed, whenever a minion tries to authenticate, an event is fired. And whenever a minion finishes starting up, there's another event. So for the purposes of this example, we are going to assume that all minions whose names start with nice are going to have their keys auto-accepted. So, first of all, in the state that's going to be dealing with authentication, we'll first want to remove the keys coming from the minions that have failed to authenticate. The next step is going to be to trigger a minion restart. And now I know this is ugly. This is just for the purposes of examples. Every time I read SSH in the middle of another language, another configuration management system, I kind of creep out a bit. But this is just an example. What we want to do is have the minion re-authenticate, generate a new key, so to speak. So reaching the end of our big state, if we are in pending status, of authenticating pending status, and the name starts with nice, we accept the key. And as for the last state, when the minion finishes starting up, this is actually good practice that you can implement. Whenever a minion finishes starting up, we apply a high state to that minion. This is something nice to ensure that all your minions are consistent, at least when starting up. Now note here that we've been hard-coding the nice and maybe some other things around it. It's because, as we said before, we don't have the grains, we don't have the pillar, we don't have a safe way to store information, make it available to the reactor. So keep that in mind whenever you use the reactor. And our last component today is going to be the API. Of course, Salt has a REST API. The main idea behind it is to send commands to our running master. And the API supports both encryption and authentication. The authentication, which is something that you might not see very usually in Salt, Salt has an external authentication system. It allows for authenticate against LDAP, against PAM. It also has access control in it. It's really outside the scope of this talk. It's a very big thing to talk about, but it is worth mentioning that it actually exists. And the entire things that are managed by the API are controlled by another daemon, the Salt API daemon. So if it's a REST API, we can, of course, use anything that can make HTTP requests and get information from it, or send information to it. In this very short example, we are making a request to a certain URI for minions, and if we pass the correct minion ID, we're going to start getting data about that minion. In this case, for the sake of simplicity, we're not using authentication here. Now, there are several API endpoints available, already bundled with the Salt API. They're pretty much self-explanatory, but let me draw your attention to one in particular, the /hook. This is a special endpoint. It's a generic webhook entry point, and the whole reason for existing is that any post requests that are done here will be generating events on the master side, on the event bus. And the post data that we send to it is going to become the data of our generated event. And another important thing, because this is a special endpoint, it's the only one that Salt allows you to explicitly disable authentication in this particular part. Another thing is, if you're disabling authentication, it does not mean that you can do whatever you like. You're expected to implement some kind of security. Why would you be disable authentication? Well, I like to think of apps that can barely perform an HTTP request, that can barely understand a URL. So they can only do a request with a special hard-coded token that you specify. So that's why we have that there. Now, how about, from all the rush that we just been in it, how about we put them all together, be nice and friends. Now, I know you might be battered here. You've seen a lot of information, and I think that you might be a little bit confused. But I assure you, we can do pretty interesting stuff with all that we saw: the events, the beacons, the reactor, and the API. Now, more graphical understanding of how all this connects together. We first have the beacons and the API. The main interesting point about these two is that they're related to elements outside Salt. You know, the beacons monitor things outside Salt, and the API, it's an API, so anybody can make a request to it. So they're both related to elements from the outside. Now, both of these two will be generating events in our event system, in our event bus. Those events can be later picked up by the reactor, given what we define inside the reactor, which then can be translated into Salt states. Now, with the great responsibility of having to manage your entire DevOps/Ops/workflow infrastructure comes a great power. And there's a deliberate reordering of the phrase here, because if you configure Salt properly, you're going to have full control of everything in your infrastructure, in your workflow, everything, and from within Salt. So as such, you are expected to know what you're doing, and you should always rely on a sensible way of doing things. For example, be aware of the security risks. You might be tempted to, give way too much power to Salt, and that's a good thing, but beware of somebody trying to do an ugly thing with it. So, to finish this off, let's take a minute, talk about what all you can do with all of this. I'll just be naming you a couple of examples from the top of my head, and leave you to think the rest. That's because that's what Salt is. Salt is kind of like a batteries-included approach to give you the space to create your own solutions, much like Python is, which is why I love Salt. So just to name an example, let's talk about self-healing. Anybody knows what self-healing is, what it consists of? Anybody heard the term? Okay, so in more humane words, self-healing is the ability that we give our applications or systems the ability to repair themselves whenever something bad has happened, whenever they encounter an adverse situation on their own. That's the thing. That's why it's called self-healing. Now, all this might just be a REST API call away, because if in your application you can identify that the bad thing that has happened can be corrected by something that can be automated, you can do it with an API call, because Salt can have control of that. Or another example, and I think many of you have encountered this, let's say half your team refuses to use Jenkins or the CI tool that you're using. Fear not, because you can leave them be with whatever they are using and integrate the rest of the push, build, test, deploy, endless CI cycle with Salt. You can manage it with Salt too. Another example, if you were talking about scaling both up or down or sideways, growing, shrinking, you can prepare for it with Salt. And you can also trust in Salt to do some provisioning. We haven't covered it here, but Salt also has a Salt Cloud daemon to provision cloud instances. And last but not least, with a good beacon setup, you can make sure that your environments are consistent. If you have things that aren't supposed to change and you suspect that somebody tends to do nasty things, with the beacons, you can react immediately upon any changes that you deem unwanted. And so these are mainly all the examples that I could think of with the short time that I was given, as I said before. I really do hope that you can leverage what you saw here to come up with your own solutions, because I'm sure that your problems might be worse than what I'm simply presenting him. So, as for the docs, and as for last year, all the documentation is in the official SaltStack documentation. I really encourage you to take a read. If you have any particular questions, there's also the possibility of bothering the guys at the Salt Freenode channel on IRC. I do that a lot. And we're reaching the end. So now we have time for some questions. So feel free to shoot away.
Can you compare Salt with Ansible a bit?
I'm going to be honest with you. I haven't used Ansible. I know that it's maybe has a more basic approach. What I've been told from the people that have tried both is that Ansible lacks some components that Salt has, like the reactor, for example. So it goes around those lines.
I was wondering how one could use Salt as a deployment tool. Is it feasible to deploy a complete web application with it, or is it just well fit to set up the system and then you need to revert to a proper deployment tool to deploy your application?
For application deployments, right?
Yeah, web application, so set up a database, do something, put some basic data in it, deploy your Django application, set up the web server, and things like that.
Yeah, maybe that was covered in the previous talk, which is more basic, but no, that's a very good question. And yeah, you can do it. You might have to handle a slightly more manual approach in order to tailor it for your environment, but you can certainly do it. And if you're thinking of doing some bare metal provisioning, you can also do that, not exactly with Salt on its own, but Salt has Foreman integration. Foreman is a provisioning software that was mainly written for Puppet, but now has Salt integration. So you can do the whole cycle from it.
Hello. I understood that the communication channel is SSH. Is it correct?
Salt has a way of working with SSH, but it's not the main way that...
What I want to ask is, how do you handle minions that are running Windows?
That's a very good question, actually. It is possible, but I'm sorry, I've never had to do it.
I have been a little bit playing around with that and found a way to insert an SSH daemon in Windows as using SugWin that has an SSH. It seems to be working. I'm just curious if there's other options.
Yeah, I mean, as long as you are aware of any limitations that you might have, it should work. The rest of the system is shared and it's the same.
Thanks for the great talk.
Thank you.
I'm using Salt for 3 months, it's really cool. There's also one stuff we're using, it's engines, getting some additional events. And currently I'm looking for the way to make pillars dynamic. I mean, I want pillars to get information from console or from etcd during deployment to get some key information from key value storage external. Is it possible?
I will have to look that up. Not entirely sure, but I mean, everything appears to be extensible in Salt, so I don't see why not. Yeah, maybe it is.
Hi, how do you upgrade Salt without SSH? Or is there any good approach to do that?
Upgrading Salt without SSH, you mean the master and the... I don't think I understood where you were going with the question.
And how do you upgrade the Salt? Like install new version of Salt on the current machine?
Oh, you need to have access to the system. You need to have access to install the new version, and you also have to restart the agent. Now that's one thing that is still not handled very well in Salt is restarting minions whenever there's an upgrade, because you can't do it from inside the master, because you're going to be losing communication for a bit. So, that's what I mean. Yeah, it's kind of a tricky spot still.
Regarding the question about dynamic pillar, I think it's possible. Salt has a mechanism to get a pillar from external services. You can implement a Python module to... There is a plugin called Request, which uses that to make pillar more usable, in fact. And the question is, how do you test your states? We have several breakages in production due to human error.
I know. I don't have a production system. I mean, I use Salt for personal uses. I never had the luxury of working with the Salt environment, but I know where you're going with it. It would be nice if you could have a development environment or QA to try things out. Because once you've made a change to a state and Salt doesn't like it, it will blow up. So it's kind of tricky. You have to keep looking at the logs and be very careful what you changed. You're bound to have the last change that you made cause a problem if you see a problem. Hi.
Is it? Yeah, it's working. How do you handle provisioning new servers, and how do you handle your inventory of servers?
Well, okay, let's answer the first question. Provisioning is done in two parts. If we're talking about bare metal provisioning, you have to use something like Foreman that allows you to boot a system and then apply Salt states to it. So Salt is not, it's like Puppet in that way, and it's not like Ansible in that way. It doesn't have the ability to provision a system from bare metal from the ground up. When the system is already installed and has a minion running, you can do whatever you want with it. As for the catalog, the inventory, from the perspective of the master, all the master sees are minions. So it is up to you to group them using node groups or grains or whatever you deem to be necessary. You would be basically setting your categories on your own, building node groups, setting grains on certain minions to identify them from the perspective of the master, but essentially there is no way of distinction. In fact, when we talked about the syndic node, the main master, the master of masters, will see all minions connected to it, even those from lower level syndic nodes.
So this is in response to the question about testing the salt states. We do this. We will use Vagrant on your local machines with a masterless minion setup, and then spin up in number of VMs and actually test the states, at least at some minimal, so that we can catch human error like that, because we have the same problem. we deploy across hundreds of machines simultaneously, and one error can really mess up your day. So I've tried with Vagrant locally. It works pretty well because you can spin up different kinds of VMs. We use FreeBSD or Ubuntu or CentOS, and you can simulate a lot of those environments easily.
Interesting. Thank you.
Hi, thanks for the talk.
Thank you.
I'm seeing a pattern here. I'm seeing that most of the questions we are asking about salt, we think that salt can't do, can be done perfectly using Ansible, like initial system configuration, or maybe someone asked about service management.
Uh-huh.
I know you already said you haven't used Ansible, but have you heard about someone using Ansible and Salt together?
No. Pretty much when somebody chooses a configuration management system, they like to stick to it. It has to do with the learning curve and all the stuff. So it will be harder. From the very few things that I've seen from Ansible, it's quite different from Salt, even though both are written in Python, even though both use YAML. They're quite different. So, every organization wants to choose one technology and stick to it. So, yeah.
But they seem to work very well together.
Well, that's interesting. I mean, if Ansible can be used for the bare metal provisioning part and Salt maybe for the rest, or Salt for the reactors, yeah, you could certainly mix those two. You could
use Fabric, not Salt. Fabric is used just to provision from bare metal used to create a virtual machine, to install Salt Master on it, and to configure it, and then to apply high state.
Are we talking about the Fabric Python module?
Yes, right.
The one that comes from Parameco? It uses SSH to...
Yeah, right. It uses SSH to make a basic provisioning, to start virtual machine, put Salt Master on it, and then use Salt Master and the full power of Salt.
Yeah, you can also do that.
We have time for one more question. Or not.
Okay.
Thank you, guys.
Thank you, guys.
Welcome all. Here I have Daniel and Surya with me on how to improve your diet and save money with Python. Give them some applause.
Hi everyone. My name is Surya, he is Daniel. We are both students from the University of Alicante and we are both chemical engineering students. So we're not programmers. So if you see something in a code, feel free to send a pull request to GitHub. That's another thing. You can find our documentation and notebooks in our GitHub, which I will post on Twitter later. Something about us. We are both active members of KCM, which is a non-profit organization by our university. And, well, something maybe about their personalities. He is in love with interactive widgets and he loves them. I actually don't like them so much. And, well, we are Program-Led Science 2014, so we are beginners in this. And something about the talk. We are chemical engineers and we love reactors and distillation columns. But I don't think you are much chemical engineers, so maybe it will not be interesting for you. So we were thinking, what is everything every one of us eats? And well, every one of us wants to eat the most, but pay the minimum of money. So, but all of us have the objective, now it's summer, so we all want to fit and be healthy. So we are going to show you how you can optimize your food with a minimum cost, but having the nutritional concerns that you want to have. And well, now I'm going to let you, Daniel, who's going to tell you something more about the theory of this optimization problem.
Thank you, Surya. There are no interactive widgets here, so don't be afraid. Optimization deals with find a minimum or a maximum or zeros of a given function, and we're going to see some concepts using the diet problem. This problem was known in the early 40s when the US Army wanted to minimize the cost of food and give their soldiers a balanced diet. To understand this better, I will give you an example. Imagine we move the problem, the diet problem, to the present time. At this date, it is common go to a fast food establishment to eat, and we want a cheaper meat, and of course we want a healthy meal. So this is our problem. When you go to this establishment, you can choose some products like fries, like hamburgers, and this is our variable, named as x, in our mathematical problem. Each product has a price, and the total price is the multiplication of all coefficients by this variable, and later the summation of all of them is our final cost. What we want to do is minimize this cost subject to constraints and nutritional constraints. So this is our mathematical problem, and we are going to optimize this using Python. But first, we have to see some concept about of optimization. I wish my professor showed me at the very beginning, and I'm going to show you in 10 minutes. So first, what is a linear function and a nonlinear function? As you can see here, this is a linear function. It's correct. It's a line, yes. And, well, this is a nonlinear function. You see, it's not a lane. Okay. Thank you. You can perform this in 3 dimensions. This is a plane, and a nonlinear function looks like this in 3 dimensions. Well, smooth versus non-smooth. If you have something like this is a function where you can calculate the tangent in all the points of its domain. So this means that this is a smooth function. Great. And for example, in the vertex of this other function, you cannot calculate the tangent. So this is a non-smooth function. This is important, and later we will see it. And also in 3D, in 3 dimensions, this is a smooth function. And as you can see, also a vertex, this is a non-smooth function. Many optimizers use the gradient of a eigenfunction to solve the problem. You can, in more cases, this gradient is not given, so you have to calculate it numerically. So if you have a noisy function, this is so complicated, and you not be sure that don't have mistakes. So to optimize, we prefer the green graph, the exact function, so non-noisy function. Well, if you have something like this, it's a convex function. When the tangent in a point is completely horizontal, you could have a minimum. In this case, you only have one point, and it's the lowest point, so it's a global minimum. And of course, if you have more than 1 point that have the horizontal tangent, you have more than one minimum. In this case, you have the lowest value for the function is the global minimum, and you have other minimum that are the local minimum. This is so important. And why is this important? When you are solving this type of problem, you don't actually know the value of all the points in your function. So it's like you are in a fog-covered mountain, and you only have the information of the nearest region. So it could be possible that is the fog going out, well, it could be that you are not in the global point, in the global optimum. Well, and what is a convex and non-convex function? This is a convex function. Imagine if you choose any 2 points in the graph and you trace a segment line between these 2 points. If the graph is always down the segment, you have a convex function. If not, you have a non-convex function. Yes, easy. And also in 3 dimensions, convex and non-convex function can be done. So this is an important chapter. What is a constraint? Constraint is a function that limits your search space to find a minimum. Imagine we have this function. This is the contour of the function, and the lowest point is the black point, the global minimum. If we have no any constraint, our optimum point is the black point, the global minimum. Okay? So we can have different types of constraints. Like this, a quality constraint, that means that the optimum point must be inside our restrictions. So the solution for this problem is in the red point. This is the optimum. And as you can see, is the clear point to the global minimum inside these restrictions. You can have inequality constraints that allows you to search your optimum point over the restriction or under the restriction. In this case, as you can say, you can search your optimum point over the inequality constraint, and of course, yeah, great. The optimum point is the global minimum of the function, so it's fantastic. And you can have the other case. You are only allowed to search the optimum point under the constraint. So your solution is this red point, and you can ask me, it's a little far of the global minimum, yeah, but this is your problem, and this is the better solution for this case, because you are a constraint, and this is so important. Of course, if you have more than one constraint, you can perform a little search space to find the minimum. And as you can see, the red point is another point, right? Of course, this region that you form with a constraint should be a convex region to be sure you are in a global optimum point, because if you have some like this, you never could be sure you are in a global optimum. You only can assure the solution is a local minimum or a local maximum, but not the best solution. Well, most of the figure and script from Europython and SciP lecture. Thank you, Gael Rakos. Well, attending to this, the optimization problem can be divided by using these ideas. If you pay attention of your objective function or your restriction, you can ask, well, it's a linear, it's a non-linear, or we have decision variables. That means that you can do a choice. For example, I only want a vegetarian menu, or not. It's like 1 or 0. There are half my problem binary variable, yes or no. So we can have linear programming problem, mixed integral linear programming problems, non-linear programming problem, and the most difficult mixed integral non-linear programming problems. And each one of these type of problems have a main algorithm to solve it. For example, we use the simplex algorithm to solve linear programming, and later theory show you a little bit. Well, an optimization model can be defined mathematically as follows. This is our problem, the diet problem. And as you can see, there are only letters, but don't be afraid. In Payomo, this is not that abstract model because we put the coefficient and other parameters externally. And this is a concrete model in Payomo where you put explicitly the value of the parameters of other coefficients in the problem. So now I'm going to change. Okay. Well, the optimization problem could be solved through a solver. A solver is the implementation of the main algorithm showed before, and some of these solvers could be that you saw here. For linear programming, we can use GLPK, PULP, KWix-ODD, and for example, for mixed integral nonlinear programming, we use Baron and Simplex. Simplex is fantastic. Really, really. Well, we can use this solver through an algorithm, through algebraic modeling language that is a high-level computer language that support formulation and analysis of large mathematical problems. Some of them are AMPL, GAMS, AIMS, and of course, Payomo. Payomo is interesting because it allows the formulation of algebraic models using Python, and this is great. And it's communicated with principal solvers, even NeoServer. And why Payomo? Well, why not Payomo? Yeah, Payomo is an open source, has a solver integration, and has several advantages over custom, like it's a robust language, has extensive documentation, a rich set of standard libraries, and more. So why not Payomo? It's a good option. So for studying Payomo, we have to thank Juan Luis Cano for his help building the conda site for Payomo. Juan Luis is also in the conference. Thank you, Juan Luis. And for installing, you only have to type this line code, and you have to install the solver separately because They don't have implemented in the installation, but it's not a problem. If you want to install GLPK to solve LP problem and mixing integral linear programming, type this. And to solve nonlinear programming, you can use EPOP, type in this other line. And you can install some extra, like Neo Server, that is the free internet-based service for solving numerical optimization problem. And it's so interesting. For more information, click the link. And now I give the word, I don't know how to say it, to Thuri, that is going to explain the program we perform.
We are sorry for that much of theory, but if we don't show you that, you will not understand what I'm going to show you now. So I'm now going to show you the practical part of this. So now we're going to improve our diet. And, well, our problem is that, like Danny explained before, but we have two cases. The first case is we set our menu from a fast food restaurant, and we want to minimize the cost, but eat the healthiest way. So we have a lot of constraints. We have to minimize our function option, and well, all that have to be the optimum solution for us. So how I did this? I actually am not good with guideline daily amounts and this stuff, but I was searching on the internet. And well, I found a lot of data about the input of daily nutrients you should eat a day. What you can see here for different women, men, children, that what you should eat a day. It's a little bit, I don't know if someone does that. But well, using this, I have done the problem, I've solved it. First, we need to import Pyoma. You would say we are importing everything, but it's like, it's convention in Pyoma, so you do this because it's like this. Then I got the data. I have to say, the data, it's not totally real, so everything what could be real, it's fiction. And you will see here is my data, and we have, I don't know if they will let me show you, but in this data, we have our menus, the costs, and then on it, I will show you later if you want, we set our parameters, will be our constraint values. It means in this case we have calories, sugar, proteins, and some of this stuff, and I've settled maximum and minimum values I want in my diet. So solving this problem, first we need to input the model. This type of problem is a linear problem and an abstract model. So we set the sets. The sets is the data I use to get the model in. And in this case, we have the products and the nutrients with their parameters, which are data which depends on the sets I have set before. And we have cost, nutrients, and a maximum and minimum of each nutrient. So, which of course we will default 0 and infinite. Then we have our variables, will be in this case the number of servings, what we're going to take. Our objective function is to minimize the cost of the food, and it's the normal structure of our object function. Our constraint, which is I think the most difficult part of the code, because you have to look what you're going to do, and later I will show you a more difficult problem like that. And well, this is very easy. We have maximum and minimum, nothing more. And solving the problem, that's what Pyoma gives you as a solution. You see, you have one solution, which is great. We have a function value. It means we have minimized our cost to €369. And well, he finished everything done. And the solution he does for us is this. But it's not showing my solution. I don't know why. Under it, what you don't see, he gives you the answer. It makes, in this case, you can eat one Big Mac, and you have optimized your diet. You see, that's everything you can eat in one meal, of course, because you have... Yeah, but only the hamburger, you can't eat the fries. Only hamburger. You have to say, here, you see, that's a normal graph of what we've called Big Mac. You see, this black one is the daily amount in one meal you should eat, but this type of food has a lot of salt, a lot of fat, so, well, if you want to eat healthy, you go there and eat a Big Mac. It will be great. Now I'm going to show you something very different. I like this problem a lot because I was thinking what can do more with the diet problem. And I was thinking, well, now we're going to do the opposite. It means how much calories I can eat in one meal for only €5. And it was like, wow, I go there and eat a lot. So no. Well, I do that. Yeah, it was like, let's eat. And, well, we do the same. We do the import of PyMO. We get the data, which you will not find that there is a dead link. McDonald's app, I don't know what's happened. Well, and to solve that, it's an abstract model. We set our sets, or parameters, but in this time you say it's not the nutrients we're going to set to maximum and minimum, this time is the cost, 0 and €5 in this case, our variables are the same, and our objective function now is the calories, but we want the maximum. You see, PyM is very visual and very easy. You see there the sense, when you want to minimize, you put there minimize, and when you maximize, put maximize. You don't have to do anything more. And well, our constraint now it will be on the cost, and our solution we got. You see, you can eat in one meal 2,690 kilocalories for €5. So you eat that what you should eat in one day, which I think it's respectable for €5. And the solution is this. You should eat 3 hamburgers for €1.29 and 1 package of grilled onion rings, which I've never seen here. Now, I'm sorry for it, but we are chemical engineers and we love reactors and distillation companies, so now you're going to see the problem we solve normally. And, well, that's our problem or example. In this case, we solve chemical engineering, chemical industry problems. So we optimize our ways to get a product and to minimize our environmental impact because we deal with a lot of chemical products and something like that. So to make it easy for you, we have products which we can pass with a reactor to a final product, which will be beer in this case. And then we can separate water from the alcohol with distillation, and we'll get whiskey and water. But we can do it with 2 types, reactors. We have batch and continuous, which means a batch reactor. It's what you do in home. You put your water in and stop the reaction, eat it, and then put another boiling water on it. Continuous, it will be there how much time you want it. And distillation, the same. You have a batch reactor, which is, I think it's on a Simpsons Capital. They explode the thing. But you can do it in short times or in long time for continuous. And, well, that's not what I'm going to show you. We have this superstructure. We have A, we want to get it to B and then to C. And we have 2 ways to get it. We have a reactor, we have a lot of distillation columns, and, well, we get PyM to say us what we can do with the minimum environmental impact. And, well, we have a lot of reactions. As everyone is interested in, you can read them all, but I don't think you'd want that. Here we have an interesting fact. We have disjunctions. This is the first time you will see them. Disjunctions, you have to imagine it as like 2 situations. We have situation 1, which is when we have situation 1, the cost, and every product will be this data. But if this situation is not going to happen, we have the other. It means everything is zero, so this part is not existing anymore. And that's the hardest part to deal with it on PyMO, which if everyone is interested, you can come to me outside and I will explain you how to do it. So now we are going to introduce binary variables, which is, everyone I think knows what a binary variable is. 1 or 0, well, it exists or it don't exist. So, optimizing or finite objection, you see this time it's not a lovely linear problem. This time we have a real expression with everything math stuff. And now I'm going to show you the results because the code is very, very long. These are the results, what we should do. So you say, PyMO, you can use it for everything. To go to McDonald's or to make your own reactor at home and settle, I don't know, whiskey, beer, what you want. So you can use everything of this for your own choice. And last but not least, I have to say it, I said before, because we are both part of CATEME, which is a non-profit organization from the University of Alicante, which encourages chemical engineers to use programming, because we actually don't learn to program in our studies. And, well, we have to thank, if you want to say, there's the homepage. And we have to thank a lot to our teachers, Fran Navarro and Rubén Ruiz Femenía, which have helped us to do this. And I hope you enjoyed the speak.
Hi, I wanted to know if you know what are the methods for optimization that are used inside PyMO or any of the tools that you are calling from it. Like, is it iterative? Is it iterative way? Is it a Newtonian? Is it a conjugate gradient? What kind of method of optimization is done to arrive to the minimum?
Because you go deeper in iterative. It's normally it's an iterative way. So he tries every thing and he wants to choose how the solution will fit everything. But normally you have seen a very simple problem. But before I showed you, you have, I think, 29 equations you have to optimize it because the solution needs to fit every of them. So sometimes it will be a good solution what you get, but sometimes not. So you have to play a little bit with that. We normally use GAMS, and you will see the code is on there too, that they give very similar but not the same solution for you to the same problem, because every solver had his own stuff. I don't know if that's the answer to your question.
Okay, if it's iterative, I understand that you could end up arriving to local minimum.
Yeah.
No, it's okay. I can shout.
They won't be recorded.
Thank you very much for the talk. With the optimization of calories for €5, did you have any constraints as in non-toxic level of salt or fat? So can you survive those calories, or it's just did you have no constraints?
I was looking at that, and I seen on internet that you should eat 2 grams of salt a day, which is every of us, I think, eats a lot more. And I was looking at it, and I think if you eat that much of calories and of salt a day, maybe you go to the hospital on the next. So it will be, I don't think you can eat that much for one meal. It will be too much for you to get that.
3 hamburgers and 1 onion.
No, there are the 2,600 calories, I mean. Yeah, the problem is that food had a lot of salt and sugar, and that's too much you should have in your body, so you will have problems later maybe. I don't know, if maybe not. You should try it. You should try it. For science. Please send me a message if you have tried, if you're okay.
Hi, thank you for the talk. I have a question. why can't you drink this water? It's whiskey water, basically. Drink and drive, you know. Why? There's water waste, don't drink that. It's water. It's whiskey water, right? I will buy it.
Okay. That's because you have to study a little bit about the distillation. You have a lot of types of different alcohol types in whiskey, and you have to see there are some types you can get blind from it. So that's what you are extracting, and that's in the water. So maybe if you, yeah, it's water.
There may be some molecules of water in it.
Normally, everything what we got in the chemical engineering production, you don't should eat it or taste it. Well, I don't recommend to drink that.
So does that mean if you mix wastewater with whiskey, then you get beer out of it?
No.
Okay.
It will be great. It will be great.
Okay, my actual question. Is it possible to have the two objectives? I think you implemented now the nutrition constraints as constraints.
Yeah.
But can there be two objectives which are somehow weighted that you can say, well, that you can compromise between nutritional value and money spent? So it's fine if the nutrition value is not quite as high if you save €2 or something like that.
Well, yes, you can perform a multi-objective exercises, but not using this technique. For example, if you are interested in optimizing the cost and the medical care, there are two objectives that are different, so you have to use Pareto on other techniques, not using these techniques. But yes, you could do it, but using other things. This is only for one objective function.
Yeah, you can do it.
Yeah. If you want later, we can talk about it.
What you can do will be easier if you want to do it this like this. You can transform one of the function objections in a constraint.
Yeah.
So if this is satisfied, you have two function options. You only have to do what are you dealing with. It's, do you know what you're doing? What normally we don't know. So the speak should be for 45 minutes, but I was a little bit fast, so I'm sorry for that.
Don't worry. Any more questions? No? So we can have our free meal. And thanks for coming. Thanks for our speakers.
benefits.
Talk, automate, contribute, repeat with Theo. Welcome new people. Give him some applause.
So, hi everyone. As a disclosure, my excuses for the nice Chrome bar. I just started with this Reveal GS thingy and I can't get it to work properly, so whatever. So we're going to talk about automation and as a short presentation. So I'm Theo. I work for Europython. And basically, I tend to describe myself as someone who whispers to computers. Like, I'm more of a hacker than a proper scientific engineer. So, working with computers is pretty cool, right? But making music is definitely way cooler. So why don't we basically achieve the dreams of our grandfathers and so on and make computers work for us so we have more time to make music? So if you don't know Ableton, we are a music company. We basically build softwares and hardware that enable music makers from building a track to playing it live. The company was founded 16 years ago, so we're not exactly a startup anymore, although we're still a rather mid-sized company. We're Berlin-based, and the company was founded in Berlin by Berliners, and our founders are electronic musicians. Well, not anymore, but they have been electronic musicians for a while. Our most known and used product so far is Live. Live is what we call a DAW, so basically it's a software that allows you to build a track and to perform it live. It's based on two views, the one you see here that we call the session view, where you basically create clips. So it's small loops that you can play and you can arrange as you want. And right now, in the, let's call it the mainstream music industry, it's one of the most used software. We also have Push. So basically, Push is some sort of fancy MIDI controller. So if you're not familiar with music, it's basically an interface that will send signals, notes, like a small protocol, that will tell the computer what kind of sound to play, at what pitch, and when to play it. And finally, we recently released Link, and Link is an iOS framework that synchronizes devices, and more specifically, synchronizes their bit time. So, for example, if you're making music on your Mac, and someone comes in with an iPad, they can connect to each other, and you can be sure that they will play in time. So if someone is starting a drum beat, for example, and you had a bass line on top of it, they will play together on time. There won't be any phase or any weird stuff like that. And we basically provide it as an iOS framework to developers, and they implement it in their iPad apps. So these projects are big and complex. When I say these projects, I tend to include Live, Push, and Link all into the same bucket, because basically they are all part of one big ecosystem. And if you think of Live more specifically, it's a huge monolithic C++ code base. So we basically have, I think, millions of lines of code and thousands of files. They involve Qt, which is a huge library for basically building GUI. We include Boost too, which is a big C++ library that does all sorts of fancy stuff. And we have Python in the build system, and it's also included in Push, so for the communication layer and for scripting purpose. Now, what's interesting in this is that I was working in startups before, and I was doing backend and system tasks, basically. And I could use all sorts of fancy tools, right, like Docker and all this stuff. I could deploy stuff on AWS. It was not a problem. And for one simple reason, it was that we were using Linux. And once you get out of this ecosystem, you realize that if you have to build something against OS X, Windows, or iOS, well, all these tools become suddenly, most of these tools become suddenly unavailable. But still, we're not doing rocket science, but what we call DSP, digital signal processing, is serious business. It's a very complex topic, and most users rely on our software's reliability. So basically, if you're Skrillex and you're playing in front of, say, 40,000 people, you don't want live to crash in the middle of the gig, right? Same if you're playing at the Berghain in Berlin during all night. You don't want it to just stop or start doing shit in the middle of your set. So although we don't have access to all these fancy tools to help us build a better software faster and in a more secure way, we have to find a way to reach that level of quality. The live ecosystem involves long build times. So basically, I think we have the same kind of problematics as projects like Chromium, for example. We are building a huge software that takes a very, very long time to build sometimes. That involves a very complex and long workflow, like from a feature ID to its implementation. It can take up to months, sorry. And we also have a culture of perfection. So as I said, when we put a release out there, we don't want users to have the software crashing in the middle of their set. Also, something very specific to this class of software is that most people that work in studios, for example, don't have internet. So they won't update their software all the time. They will update it from time to time. But we also are aware of users who are running very old versions of Lives and are not wishing to upgrade it. So all of this leads to the need for automation. So we have to automate as many things as we can, whenever it comes to build it or whenever it comes to release it. So sure, you could tell me we could automate everything with scripts, like with bash scripts, Python, Fabric, you name it. Actually, we use basic scripts, not basic, but scripts for the build system already, which are in Python. But if you ask me, scripts are very hard to keep organized, to maintain sometime, and I'm thinking more of bash scripts here, and I'm not even talking about extending. And yeah, let's just be honest, like, scripts are cool, but scripts are hard and very often cryptic. I wouldn't read some of my scripts from 2 years ago. We could also use proper deployment systems. Many of you probably already know of Puppet or Chef. I used them in the past to deploy from mid-sized to big infrastructures, and I really enjoyed them for many different reasons. But in general, I find that these tools always involve the concept of nodes, of leader, follower, and they're not really suitable with something I really, really like when it comes to deployment, which is masterless systems. I don't want to have to think of, oh, do I have my client installed on this server, and where's my master, and can they talk to each other, and all this thing. When I want to deploy or automate something, I want it to just work. And also something that's a bit too much to my taste is that you have a ton of useless abstractions. And here I think more of Puppet rather than Chef, but I don't want to have to learn a new language. I don't want to have to think of where do I put all these columns and all this stuff. So basically the systems are great for a certain class of systems, but when you think of Ableton and what we're doing, it doesn't really fit. So that's why I introduced Ansible when I arrived at Ableton. If you're not familiar with Ansible, it's a deployment system just like Puppet or Chef, or you have others too that I won't name. And Ansible is basically declarative. So it's based on the YAML syntax, everything is written in YAML at all times, apart from host declaration that you do in ini files, but that's really a minority of the files. And you just state what you want to do. And if you look at this example, you can see that you have a name for each task, and then you have a module. So for example, the first one is Homebrew, and then you have a copy, and then another copy, and then you say, oh, I want a file being created. So whenever you open these files, you don't really need to make any specific effort to understand what's happening there. And if you compare that to a bash script, I can tell you it will take you probably 5 minutes in the most complex cases to understand what this is about, whereas a bash script with all this -e, blah, blah, blah everywhere, and you'd never really know where to put the square brackets, just, let it go. Another thing that's great about it is that it's sequential. So everything will be executed in order. And it will only rely on the structure of your project. So Ansible enforces a very strict structure where you define roles and you define variables, and they all work in a scope system. And once you get familiar with it, it's very easy to understand what's happening and when there's an error, where it's actually happening and why. Because you just have to follow the white rabbit. Something I really like about it too is that Ansible has few but very efficient abstractions. I can name a few of them. The most common is register. So register is simply declaring a variable. So you take a task, so all these steps that you see are called tasks, and when they're executed, they return a Python JSON object. And this object is basically describing the outcome of this task. And in this case, you can say, well, I want this JSON object to be called, in the case of the first task, foo exists, and you can later on use it. So for example, if you look at the second task, you have when foo exists is false. So when is another keyword that basically helps you defining conditions. You have with items that you see in the last one, so I can create a variable somewhere in the variable files, and I can call it my precious files, of course. And then if I use with items with my variable, I can just pass around this item thingy to my expanded strings. And that's another really great thing about it, is that all of these values could basically be strings, and they can all be interpolated with the Jinja 2 syntax. So you get a lot of flexibility, and it's still at a very low level because you only have variables, conditions, and loops, basically. That's the only thing you get. But you can mess around a bit with it to gain some flexibility with some templating. And as I said, everything there relies on the project structure. And you can modify it a bit, but canonically, you always have only one way to organize your project, to organize your roles, and to organize your playbook. So the project is the top-level structure. And it's the first example. And you can see that it's not all the things you can put in there, but the most important are there. You have the group vars. So in Ansible, you define groups of hosts. So for example, you have, I don't know, Windows servers or web servers or DB servers. You're going to create groups, and you can attach vars to these groups directly in these files. You have the inventory, where you're going to reference all the hosts that you want to talk to. You have the roles, and roles are basically kind of modules. So you're going to define a role for Nginx, which will be in charge of deploying an Nginx server. You can create a role for installing Docker, for installing Homebrew, all this kind of stuff. And something very cool too is the vault. So I will talk about it later, but Ansible is able to encrypt all your secrets, and you can access them later on in your tasks seamlessly. In these roles, you have files, templates, tasks, handlers, defaults, meta, and variables. Basically, files and templates are basically the same thing. So you locally create files or Jinja files, and later on you can say, well, I want it being created and replace this variable with this value. Tasks are what I was showing before and that you can see underneath. It's basically all the steps that the system has to go through to generate the final system state that you want. And variables are like, well, I want to match variables to values. And another interesting thing are the meta, so it's basically for including things. So if you say that Docker relies on some fancy Linux kernel or file system that you have created, you can do it there. And all of this is aggregated in small files that we call playbooks. And a playbook is basically binding all of this stuff together. So you give it a group of hosts or a single host that you want to run your project onto. You tell it what kind of connection it should use, if it should use facts, which are kind of reserved variables. You can provide it var files. So in this case, that's a vault file. So you can say, well, I have my secrets vault, which is encrypted in AES-256. You can define your own vars. And finally, you can whether call your roles. So in my case, it would be OSX Jenkins slave. Or you can also call a task directly. Another really awesome thing about Ansible, and that's mainly, I think, why I personally prefer it, is that it works over SSH and WinRM. Everything you do is done over SSH or WinRM. And what that basically means is that Ansible is able to deploy as many servers as you want in parallel on a normal laptop, as long as you have an SSH connection. WinRM is a bit more tricky because you have to make a bit of setup on the Windows side, but still it's pretty trivial. As I mentioned before, you have a vault that comes in with Ansible. Something that's great with that is that it's yet another YAML file. You basically put variables in there, and then you say, hey, Ansible Vault, this is my file, please encrypt it. I don't want people to see my GitHub, my token, my AWS token on GitHub. And then all you have to do is just, when you run Ansible, you just said, hey, well, this is my vault and this is my password, and deal with it. You have a Galaxy, which is a pretty fancy name if you ask me, where you can upload your roles. So say you have created a specific role for whatever, you can upload it and share it there. And when you want to make something very common, like, I don't know, install an open SSH server, you can be sure that someone will have made it there. But I will talk about it in a bit more detail later on. Bref, Ansible is straightforward if you compare it to other alternatives. Now, I'd like to go through some use cases that we run through, because we don't really have the same use cases as most companies that are there, I think. And I selected like 3 use cases that are pretty representative of what you can do with Ansible. So basically, you can use it to automate your computer. And what I mean by that is that you can just deploy your workstation. You won't ever need another bash script to do that anymore and deal with, oh, am I on OS X, am I on Linux, or whatever, and use this weird syntax. The last bash script you will use is the one to automatically install Ansible on your machine. And that's what they call, that's what Brew calls tapping, but basically telling, for example, Homebrew, which is the package manager, one of the package manager for OS X, where to go find softwares. And it's really as simple as telling Ansible in an inventory file, well, I want to talk to localhost, and just use the local connection to do that. And then you have 2 different commands there. You have the Ansible playbook that runs the playbook file I showed you, where you can call roles, call tasks, and variable files and all stuff. But you can also use the Ansible, just Ansible commands, and you can pass it host, and then give it just a command to run on the command line directly. And what you can do with that is that if you're on a Mac, for example, you can automate the installation of system packages and your dev tools and so on with included Homebrew package. So as you can see, you define a variable that's a hash map in which you say, I want mock and widget and whatever. And then later on, you can just say, well, I want to install all the elements in Homebrew packages, and I want the latest version of it. Same for your desktop app. Like you want to have Spotify, VirtualBox, whatever you like installed. You can do it too with the other module that's called Cask, because of Homebrew Cask, which is a subset of Homebrew. And something that's worth mentioning, though, is that although you have the interface for that directly in Ansible, as for a lot of services like Console, for example, you generally have to install Homebrew by yourself. But Ansible can do it for you. You can write a role to install Homebrew. You can use it to set up your dev environment, so you can update your system settings. You can install, pull and install your dot files, and you can also pull some favorite Git repos. You could also trigger some builds, anything you can think. That's really the great thing about it. So to sum it up, it's like you do the work once, you keep it up to date, and you will never, ever lose hours reinstalling your workstation. And I also tend to think that it's pretty great if you're looking into a good solution to onboard some engineers. Like in our case, we could perfectly say that we install all the Xcode toolchain and all the CMake stuff, all the Jeep stuff, directly with just one command that's based on an Ansible playbook that we would keep up to date. So you don't really need shell scripts anymore to do this stuff. And actually, something that's really awesome about it is that it works on most platforms. So whether you're running Linux, OS X, or Windows, it will work the same way. You might have to use some dedicated modules for Windows, but that's basically it. And you might have to set up a bit, but that's Windows, right? You're used to it. Now, something we do too is to deploy, well, nothing fancy, but small apps in the clouds. I can think of two very simple examples. In our offices, we have a gateway, so we have a big firewall that's keeping people from going on websites they shouldn't go on, right? So we deploy a gateway, we deploy some small dashboards to analyze what our users are doing with the software, how reliable it is. And so the process in this case is still pretty straightforward. You create a Docker image of your app, and Ansible can do that for you. You just give it the path of your app where your Docker file is. You tell them, well, I want this name for my image, the repository you want to push it to. You can also tell it if you want to log to Docker Hub or to your private registry. Then you can tell Ansible, well, okay, that's cool, I have a Docker container now, but I want to deploy it. So same as with the Docker image, but there you would do it in the playbook. But so when you look at the deployment, what often happens is that in the playbook, you will first set up your environment, and what I call by environment here is like more your infrastructure, actually. So you would create your VM, and here, that's exactly what it's doing. So this local action is kind of a trick. It's not very obvious, which is not, we're not really used to that in Ansible, non-obvious things, but, well, it's that way. And you can describe, that's the great thing about it, you just describe what you want. You don't really need any logic. You don't really need to think of, oh, so what should happen and so on. You just think of your steps and describe them, and that's basically it. But you could tell me, yeah, okay, but how do I tell Ansible that, well, this VM exists now, and I want to deploy stuff on it. I want to put my Docker image, my Docker container there. Well, that's another super cool thing about it. Remember I told you about inventories where you list all the hosts you want? Well, they can be dynamic too. So you can perfectly give it a Python script, and this Python script is going to return a JSON object that's listing all the hosts that you have created on AWS. And with a few tags, you can very rapidly automate the deployment. So you create your VM, you tag it with a certain tag, and then this inventory will ensure that you have a host that's matching this tag. Once you have that, that's pretty trivial. You just bring your VM in a suitable state. So if I take the example of control, which is a small data dashboard, what we do is that we just say, well, I want all the hosts in my security group. That's another way of doing it. Instead of naming your instances, you can just refer to a security group. I want all these files to be loaded. For example, AWS is going to be all my secrets, and they're from the vault. And then sequentially, it's going to run through all the roles. So Base will create some users and install some keys. SSH server is going to create, install OpenSSH. Docker is going to install Docker. Nginx is going to install and configure Nginx. And then I'm going to deploy my app. And how I do that is just, you pull your Docker image, and you don't have to do this, but it's a pretty nice way of doing it. You create a systemd service to start this container, and you just start it. Because I will talk about it a bit later, but in our case, we use some sort of stateless machines. So when we start something, when we create a new server, it's already in a state where you just want to have to start a few services. You don't want to deploy anything anymore on it. So basically, automation is like playing a roguelike game, right? You just die and retry until it works. I'm not saying Ansible is going to solve all your problems or it's going to make your life super easier. That would be lying. But it will make the task of finding out how you should deploy and install things and figure out what's not working much easier as with other systems. And now the important bit is the dark corners I'm currently exploring at Europython. So to build the software, we use Jenkins. In the setup where we have a Linux master and we have drones that run OS X and drones that run Windows. Jenkins is kind of the nervous system of our build process. But at the moment, it's pretty old, and some people are managing it by hand. And what we're doing with that is that we're deploying Jenkins on an internal vSphere-based data center. So vSphere is basically AWS for your own data center. It's a VMware solution. And we run it on Mac Pros, Mac Mini, Windows servers. We have a bunch of data stores, and we have subnetworks to isolate everything. The reason for that is that when we build live, we need to build it on a Mac. We can't say, well, I'm going to cross-compile it for Mac, or I'm going to cross-compile it for Windows. That's not possible for us. We really have to build it on the proper architecture to make sure that everything is in order. And the great thing about that is that the latest version of Ansible that came out, I think in January, brought a lot of improvements for Windows, for VMware environments, and even for Docker. But beware, because it's still a bit buggy, and the transition was kind of tough. And as I said before, automation here happens in 2 stages. So what we want is to create a Linux master that's constantly replicated, so it can just fall and it's fine. And then we create all sorts of drones. We don't like to call them slaves. We call them drones. And this happens in 2 stages. First, provisioning, which basically is trying to create a reproducible machine state, something we can always start on. Like you press start, you know it's going to work, and it's going to be in the state you want it to be. And then just the deployment, which is basically bringing these templates to live. And in general, the only thing we have to do in the case of Linux master, for example, is starting a few containers. So if we were to sum that up, we have templates that we provision, and we deploy these templates and give them name with a convention to remember basically what's there and what's running. For the provisioning, we create a VM, we bring it in a good enough state with Ansible, we stop the VM, still with Ansible, and we create a template out of it, still with Ansible. And our hierarchy is pretty straightforward. We have a root template, which is the base OS. It's for security purpose. I can't really get into detail, but we have to do this step. Then we have kickstart templates, so we configure everything that is needed to build. So we're going to install Xcode, developer tools, CMake, whatever is needed. And the last stage is we create deployable templates, which are following a naming convention, role, OS, date. And that's it. You just have to deploy them all. Now, a bit of sugar on top of the cake. We use Console too. So if you don't know what this is, it's a service discovery system that's installed on our master and on all our slaves. And whenever we bring these VMs to life based on these templates, they declare themselves. And now all the system, every pieces of the system know each other. So if you want to automate things on Jenkins side, or if you want to make some scripting under the hood to maintain some certain states, you can perfectly do that because they know each other. Now, there's still some stones left in our shoes. Very honestly, Ansible 2.0 was a disaster. There were a lot of bugs, there were a lot of regressions, they changed a lot of things that were working and ended up not working anymore. vSphere is really nice. That was my first experience with it. I'm an AWS guy. I started my career, I always worked with the cloud. So it's pretty nice, but don't ask too many questions, right? Because it's a closed source project. And Windows support is still rough around the edges. It's a bit untested. Like what happened to me quite often is I'm like, hey, this doesn't work, I'm gonna fix it. And the guy's just like, yeah, sure, it works on my machine. So. And last but not least, Jenkins is kind of hard to automate. And now we get to the core of what I wanted to bring you guys. Ansible is the perfect project if you want to get into contributing Python code. If you're a beginner or experienced, it's a very good entry point. So Ansible is a widely used project. It's very, very active. And I think it's a super good entry point if you're looking to commit some code in a project. And when I mean code, I insist on code, like not documentation or anything, because the documentation is really great already. But you can just dig into it. Because all along the journey, you will use a lot of third-party modules and snippets. As I wrote it down, don't be a hero, just do it. There are a lot of things that are already existing that people made and problems that people solved for you. And all these modules and Ansible itself, once in a while, will have what I call less frequented corners. Things that people don't really use, like if you use the vSphere module or everything that's related to VMware, it happens quite often that something is there, it's supposed to work, but it doesn't really work. But that's actually the great thing about it, because now you can just jump into it and you can try to fix it yourself. And instead of being painful, it's actually very easy and rewarding to dive into it, fix it, adapt it, or even add something to it. And I really insist on that. It's really simple. For example, the Homebrew installer role that we use to make sure that when you install a Mac or when you deploy an OS X drone, gets Homebrew, so it's able to install the common packages. Well, this thing was mostly working, except in our network setup, because we have a firewall and we open ports on demand and so on. And I was like, well, okay, what's not working? And you just go take a look at the role, and you're like, okay, so this Git thing, it doesn't work for whatever reason. I don't really care. It's not my problem. I'm going to just go take a look at what the Homebrew script is doing for installing and trying to replicate it into the role. So you can just do that for any role you find. If you've built your own role for your own case, but you're like, well, maybe that could be useful to someone else, well, you can just publish it. Go ahead, does it, because you can be sure that it will solve someone else's problem. And for example, well, WinRM is okay, but Microsoft worked hard to provide OpenSSH support to Windows, so basically created a role that will install OpenSSH on Windows for you. And it will be as simple as including this role in your playbook. And to get to the core of it, most modules are just simple Python modules. They return formatted JSON objects, and they follow a very strict convention. So whatever you do, it's all about trying to document first what you are trying to do, and then building a Python module, but it could be anything else. If you're into, I don't know, Perl, there are still people who like Perl, you can do it. You can just create a Perl script that will return JSON. And here you can see that this is a Darwin service, so that's basically a LaunchD implementation that we worked on. And we use OSX a lot in our cluster, and well, starting services on OSX works with LaunchD, and Ansible was not supporting it. So I was like, yeah, well, sure, let's just give it a shot and try to do it myself. And it was crazy simple. You just try to find the module that's called, in this case it's service. You try to find it in their module score, so there are module score and modules extra that are out of the core of Ansible. And you just go there and go in system and like, okay, so how do they manage systemd, or how do they manage upstart? Oh, okay, that's there. So maybe I can just copy this class, try to find the method, the key methods, what they're doing, and just put my own code there. And in 1 or 2 days, maybe 2, let's be honest, LaunchD was there. And yeah, there was basically no pain. The only pain was this launchctl command. That's really weird. But also, although the code and the feature were accepted, this change happened during a redesign of the whole system interface in Ansible. And that's one of the black dots, so just know that it might happen if you go that way. That sometimes the community is like, yeah, sure, that's great, we want it, that's super code, but we are changing stuff right now. And it might happen that it just takes a while for them to just come back to you. So just bump once in a while and say, hey, what about my feature? The community is wide. There are tons of people super reactive. It's very inclusive. I've never seen a sexist comment, a racist comment. People are always trying to help. They're positive. There's no like, oh, no, sorry, that's shit. We don't want to see that. Just keep it for yourself. It's fine. It's really like trying to improve. And you have core contributors on top that sometimes comes in and say, okay, maybe this is not fitting with what we want for the software or something like that. But it's always constructive. And as I mentioned it a little bit so far, be aware that when you create a module for Ansible, debugging can be quite tricky. There are a few things to know for that. You can use PDB basically, but know that you will have to force Ansible to use on one fork, because if it starts forking everywhere, it will be really hard to figure out who is doing what and where's the error at. And it also has a ton of logging, but you have to give it some time. You really have to kind of try to figure out, okay, so this is about that, and so it just takes some time, but you will get it eventually. And yes, also something when you contribute to modules, if you take the example of I contributed a bit to some Windows modules, for example, well, it happens that the person that created it is not as involved as before, or it's in a transition state, and you might not get as good feedback as you would get on the Docker module, for example. And that's basically it. Do you have any questions, ideas, or rants? I love rants.
Hi. First, a yes or no question. Do you use Ansible Tower?
We thought of it, but I think the ratio, price, what it brings was not worth it.
My follow-up question is then, how do you ensure the state of your infrastructure? Do you have a central place where you run playbooks, or every operations guy runs them from off their laptops, or how do you do that?
So yeah, maybe it was not clear enough, but we don't really rely on Ansible for that. Ansible is really a tool for us that runs some steps, and then we flash things. So we basically have templates. And we build are infrastructure states with templates on top of each other. We just inherit all the time. And Ansible is just involved in creating the states all along the way. So we don't really need to figure out like what's the state of what. It's already there. We know what's the state of what. We have root, kickstart, and then we have our deployment images. So we don't really need this sequential states.
Now I'm not sure if my question is answered already. In our company, we have lots of small modules, and then of course the big environments where most of those modules are deployed. And well, one big Ansible playbook somewhere which deploys everything, I think, is not a good idea. So each module has its own Ansible playbook, but how do you share, for example, what is it called, roles, like where to deploy to? So if you add a new sandbox, if you add new servers, then all modules, and there can be hundreds, need to be updated in their playbooks. How do you solve that?
What do you mean with updating roles?
Okay, if I create a new module, then I create also a new playbook.
Yeah. Okay.
But if I create a new environment, then all the playbooks need to know about that new environment.
What do you call an environment? You mean like a group of machines?
Yeah, well, servers to deploy to.
Well, you use the groups in the inventory for that, right?
Yeah, but how do the many playbooks in the many modules share the same inventory?
I'm not sure I understand the question, I'm sorry.
Well,
but I'm open
I'll
to
ask
talk
later
about it
about
afterwards.
it.
Yeah, sure.
So you focused on build system in interaction with Python, but from what I know, you also use Python as embedded interpreter in life to provide ability for driver producers to implement their hardware, etc. And do you actively develop this system for embedding scripts, or rather you go away from it?
So basically, I think my colleague Alain, who's there, can talk about it. So we embed Python, but the project architecture is made in such a way that it's really monolithic and everything is there. So everything is in one place. So we don't really manage that. When we manage it, we have to do it by hand. If you want to update it, you have to update it by hand. Ansible really doesn't touch anything that's in the live code base, for example. It's something that it can do, though, is that we can install a bunch of tools that are needed to test this code base, but we never go in there to try stuff.
There's time for one more question.
Hi, thanks for the talk. Very simple one. In the structure that you defined at the beginning of the talk with the folders, we are used to have a subfolder under roles for each of our roles. And inside that subfolder, we have the files, templates, everything.
Okay.
Is this the normal approach, or are we doing it wrong? I'm not sure.
So you mean you have roles, source?
Roles, then every role has a subfolder.
Okay, so Nginx, Docker, and so on?
Exactly.
Okay.
And I don't know if that's right or not.
Yeah, that's basically the way you do it.
Well, where do you store your playbooks then?
Your playbooks that's a good question. Your playbooks stay in the top level.
Okay.
So basically you keep the playbook in top level, the YAML files, so whenever you come into your directory, it's already there. That's something I didn't mention, but we have one playbook per class of servers. So for example, we have a playbook provision Linux master, deploy Linux master. We're going to have provision OS 6 drone, deploy OS 6 drone. And then we tend to create a directory for the inventory because we have dynamic inventories there and so on. We have a bunch of them. And yeah, like you said, the roles are just enrolled and then you put them all in there. And that's really the canonical way. Yeah.
Any other like super fast question?
Or runs.
Well, another quick one. Have you configured Docker using Ansible?
Have I configured Docker?
Docker.
Yeah. Basically, we have to do it all the time. Yeah.
Have you configured Docker for user access, not root access?
No, we don't need that.
Oh, okay, sorry.
We do it for DNS and how it talks to the system, but that's basically it.
Okay.
Yeah.
Thank you all for coming. Thanks, Theo.
Thanks.